Friends, we have already seen a technique of square root where we dealt with perfect numbers. We found out square roots of perfect squares. Now we will see a technique of general square roots. This technique can be used for perfect squares as well as imperfect squares also. Meaning either you may have the answer without decimal for perfect squares or with decimal for imperfect squares. It is common. It can be used for any number of any type. Thus we have now expanded our study. So let us see how to find out general square roots. So friends, now we shall have a look at the rules that we will follow in this system. As I have written here, this technique is for general square roots, can be used for perfect as well as imperfect squares. We will be following two rules which I have written here. Let us study them. The first rule says, rule A says, after every step add the quotient to the divisor to get the new divisor. We will be doing this in steps. So after every step we will add the quotient to the divisor to get the new divisor. And the second rule says, rule B says, a new divisor can be multiplied by only that number which is suffixed to it. So we will be suffixing a number to every divisor and we will multiply the divisor by that number itself. When you read it for the first time, it sounds complicated, but it is not. When we will see examples, you will see how easy it is. So remember the two rules. After every step, add the quotient to the divisor to get the new divisor. And second, a new divisor can be multiplied by only that number which is suffixed to it. Let us begin with a very simple example. Suppose I want to find the square root of the number 529. Now, we start from the right, take in groups of 2 at a time. Start from the right, this 2 becomes a group and this number becomes a group by itself because we don't have anything else. So, first we'll bring this down, then we'll bring the whole group down. You can only bring the group down one after the other. So, let us find the square root of 529. Ask yourself, which is the square immediately smaller to 5? 1 square is 1, 2 square is 4. 4 is immediately smaller than 5. So let me do this. I will divide as we normally do. 2 square. 2 2s is 4. Now 5 minus 4 is 1. And then I bring this whole group down. 29 comes down as 29. Remember the two rules that I taught you. The first rule says, after every step, add the quotient to the divisor to get the new divisor. So this 2 I add here, 2 plus 2 becomes 4. After every step, add the quotient to the divisor to get the new divisor. So now we have 4. And our second rule had said, a new divisor can be multiplied by only that number which is suffixed to it. So I'll suffix a number here and whatever number I put here has to come here. So let me try all the possibilities. If I put 1 here, I can put only 1 here. 41 multiplied by 1 would give me 41. I need 129, won't work. 42 multiplied by 2 will give me 84. Still won't work. I need 129. Let's try the next number. 43 multiplied by 3. Yes, 3 3s will give us 9 in the end. So 43 times 3 is 129. I subtract. I have a 0 here. The moment you have a 0, your division can be complete. So here we can see 23 is our answer. In other words, 23 is the square root of 529. If you multiply 23 by 23, you will get 529. And thus you see our process of finding the general square root is complete. I will repeat the whole technique. I want to find the square root of 529. So I begin from the right, take in groups of 2. This becomes a group and the single number here becomes a group by itself. Now 5 is given here. I find the square immediately smaller than 5. I know square immediately smaller than 5 is 4, obtained by multiplying 2 by 2. So 2 times 2 is 4. From 5 I subtract 4, I have 1. Then I bring the next group 29 down. Remember our two rules. A number and a divisor has to be added after every step. So this 2 will be added here. 2 plus 2 is 4. And next, a divisor can be multiplied by only that number which is suffixed to it. If I put 1 here, I have to put 1 here. If I put 2 here, I have to put 2 here. If I put 3 here, I have to put 3 here. So here we put 3. 43 times 3 gives me 129. Subtract, I get 0. My process is over. 23 is the square root of 529. Now, but of course, when you look at only one example, it appears complicated, but we'll see 2-3 more examples, and then you will see how quickly you can get the answer in this case. So friends, let us try to find square root of another number. This time we'll take a little higher 4-digit number. Suppose I want to find the square root of 3249. I begin from the right, take in groups of 2. 1 and 2 becomes a group. 1 and 2 becomes a group. We'll begin the process of finding the general square root. Now, ask yourself, what is the perfect square immediately closer to 32? Let's begin. Immediately closer to 32, I have a perfect square. 5 times 5, 25. So, 5 times 5 is 25. I subtract 32 minus 25 is 7. And now I have to bring the whole group down. I can't bring a single digit. 49 comes down as 49. And we remember our two rules. Our first rule had said after every step, add the quotient to the divisor to get the new divisor. So 5 plus 5 will give me 10. And our second rule says this number has to be suffixed here, but whatever number you suffix here has to come here. We multiply these two and write down. So if I suffix 1 here, it becomes 101. 101 multiplied by 1 would give me 101. It won't do. I need to reach much closer to 749 or the number itself. 102 times 2 would give me 204. Still won't work. But we see 107 times 7 gives me 749. When I subtract, I get 0 and my process is complete. So we check at this point and we see we get 57 over here. That means 57 is the square root of 3249. And with this, our entire system is complete. So let us take another example of this type. I want to find the square root of 6561. This is the 4-digit number. I begin from the right, take in groups of 2. This forms a group, this forms a group. And then I begin the process of division. Ask yourself, what is the square immediately smaller to 65? Let's go ahead. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. So we are having 8 times 8. 8 times 8 is 64. I subtract, I get 1, and then I bring the next group of digits down. 161. Now we remember our two rules. After every step, add the quotient to the divisor to get the new divisor. 8 plus 8 is 16. And the second step says a divisor can be multiplied by only that number which is suffixed to it. If I suffix 1, I have to multiply it by 1. If I suffix 2, I have to multiply it by 2. So in this case I have 16, I have 16, if 1 is here, 1 is missing. So if I try 1 here, 161 times 1 would give me 161. My process is over. I am having a 0. So you see how easily we got the answer. 81 is the square root of 6561. Thus you see the Vedic math approach, and even general math has this technique. Many mathematicians use it. It is there in the curriculum of many schools and colleges. Very fast method of finding square roots. So let us find a different type of an answer where we are having a decimal. Suppose I want to find the square root of the number 656. Start from the right. This becomes a group. This becomes a group. And then I start my process of division. Find a square immediately smaller to 6. 1 square is 1, 2 square is 4, 2 times 2 is 4. So I write down 2 times 2 is 4. Then I go ahead. From 6 I subtract 4, I have 2, and then I bring this whole block down as 56. Remember our two rules. This must be added here to get the new divisor. 2 plus 2 is 4. And now whatever number I suffix here, I have to suffix here also. So if I suffix 1, 41 times 1 is 41. 41 is far away from 256. I need to reach as close as I can. So 45, if I try, 45 times 5 is 225. The more you practice your tables, the more you practice your multiplication, the closer will be your estimation. 45 times 5 is 225. Let me subtract. 6 minus 5 is 1. 5 minus 2 is 3. 2 minus 2 is 0. And as I said, after every step, add the quotient to the divisor to get the new divisor. So 5, now we'll again add to 45. 45 plus 5 is 50. Now again we continue the process. We have to suffix one number here, multiply it by the same to get the answer here. But you see, whatever you add to 50, you just cannot get 31. So we can presume that our multiplication procedure is complete over here. Still we are having 31 as the remainder. We are not having 0. So we are having some remainder. It is not perfectly divisible. At this point of time, what you can do is divide 31 by 50. When you divide 31 by 50, you will get the answer as 0.62. 31, 50, here it becomes 100, double is 62. So you get 0.62, and your final answer will be 25 plus 0.62 added to it. So 25 was there with us, and we add 0.62 to it. Our final answer is 25.62. It is not a perfect answer, but almost approximate. So you see, with this technique, we can find square roots of even those answers that have a decimal with them. Friends, let us find the square root of the number 792. Begin from here. This becomes a group. This becomes a group. And then I start my procedure of division. I have to find a perfect square immediately smaller to 7. Square of 1 is 1, 2 is 4, 3 is 9, but 9 is above 7. I want less than 7. So square of 2, 2 times 2 is 4. I subtract 7 minus 4 is 3, and I bring the next group 92. I remember my two rules. First rule had said, after every step, add the quotient to the divisor to get the new divisor. 2 plus 2 is 4. And now, whatever number I suffix here has to multiply here to get the next answer. 41 ones are 41, 41 twos will give you 84. So here, friends, as we go ahead, we realize 48 eights is 384. Then we subtract, we have only 8 left over here. 392 minus 384 is 8. Again, after every step, add the quotient to the divisor to get the new divisor, which is the first rule. 48 plus 8 gives me 56. Now, whatever number I suffix here, I have to suffix here to continue. But already 8 is smaller than 56, so I cannot continue my process. And I know I am not complete because I am not having a 0 over here. So at this point of time, I stop here. 28 is my quotient and I try to get the decimal part. 8 divided by 56 is 0.14. So I get 0.14. My final answer is 28 plus 0.14, that is 28.14. Approximately the cube root of 792 is 28.14. Let me revise this technique once again so that it becomes clear. Normally in exams they never ask such tough questions, but in this course my intention was to deal with questions of all types. That is why I am dealing with this example. I want to find the square root of 792. I begin from the right, this becomes a group and this becomes a group. Now I find out the perfect square immediately smaller to 7. Perfect square immediately smaller to 7 is 4, obtained by multiplying 2 times 2. So 2 times 2 is 4. From 7 I subtract 4, I have 3. 92 comes down as 92. Now, after every step, add the quotient to the divisor to get the new divisor. 2 plus 2 is 4. Whatever number is suffixed here, same number must come here. 48, 8s are 384. I subtract, I have 8. Again, add the quotient to the divisor. 48 plus 8 is 56. Now, we have 8 over here, we have 56 over here. So we divide 8 divided by 56 is 0.14. Our perfect quotient is 28 and the decimal part is 0.14. We add both. 28 plus 0.14 is 28.14. That means approximately 28.14 is the square root of 792. So these are examples where we saw numbers which had perfect square roots and numbers which had imperfect square roots. In my book Vedic Mathematics Made Easy, supplied to you along with the course, you can find many of such examples of perfect as well as imperfect square roots. So friends, with this we complete this study of general square roots.